Welcome guys to the second problem solving section. In this section I'm gonna solve three questions of chapter 1 of fluid mechanics 1, sections 1, 4 to 1, 9. Follow me with the questions. First question number is 1.34 from measures of fluids, fluid mass and weight, section 1.4. In the first question, we have a cup having cream in it with the density of cream is equal to 1005 kilogram per cubic meter, which we're gonna pour it in 3 cups. The question wants us to verify a specific weight as well as specific gravity of whipped cream. So we just have to verify a specific gravity as well as weight of whipped cream. Whipped cream. So let me just erase the specifications of the question in order to provide you the solutions in a right and detailed way. So the mass of cream is equal to rho density of cream multiplied by V of cup, which is 1005 kilogram per cubic meter. And the mass of whipped cream is also equal to this. So we have density of cream multiplied by volume of cup, 1 cup divided by volume of 3 cups, which is x, and this is 3 of x. We have gonna omit x and x in here, and instead of we're gonna have substitute 1005 kilogram per cubic meter for density of cream. So this is 1005 kilogram per cubic of meter. So we are gonna have 35. Let me just go over here. 335 kilogram per cubic meter for density of whipped cream. So as a specific gravity, let me raise here. As a specific gravity, we have density of whipped cream divided by density of water at 4 degrees Celsius, which means this is 335, this is 1000. Both of them are in unit of kilogram per cubic meter. So for SG we have 0.335, which is a constant. Let me just write it correctly. For a specific weight, we have gamma, a whipped cream, which means density of whipped cream multiplied by gravity. This is 335, and this is 9.81 meter per square second. Just write it down correctly. Meter per square second. And this is kilogram per cubic meter, which we have 3,200. 3,290 Newton per square meter, which is equal to Newton per, which is equal to Pascal. So, in the first step, we had to verify the specific gravity which was gained from the whipped cream. The density of whipped cream is the density of the cream, which is 1005, divided by volume of 3 cups, because we had a row of cream multiplied by volume divided by the volume of 3 cups, which was 3, and this was 1. We had 1005 here, which we gained 335 kilogram per cubic meter here. And for specific gravity, we had to substitute the density of whipped cream here, which is 335 kilogram per cubic meter, divided by density of water at 4 degrees Celsius, which is 1000. The specific gravity is going to be gained as 0.335, and the specific weight of whipped cream is going to be density of whipped cream multiplied by gravity. Doing the multiplication, we're going to have 3,290 Newton per square meter, which is Pascal. I hope you have verified this question correctly and in detail. Follow me with the next question. Welcome guys to the second question. The second question number is 1.64 from section 1.6, viscosity. In this question, we have somehow difficult specifications to verify, which is determination of a velocity at the end of a slope direction with regarding shearing stress. The question's figure is something like that. There's a plate over here, which is having velocity of v. The slope is 20 degrees, and we have a 1 millimeter gap here, 0.1 millimeter gap. And we just need to verify the velocity. In the first step, we have to draw the body diagram, which is in this way. We have a sloped body, which we have a shearing stress here, tau A. The velocity v in this direction, the weight, force, and the origins are in this regard. Based on Newton's second law, we have sigma of Fx is equal to 0. If we project the weight force in this direction, we have weight multiplied by sine of 20 degrees. Because in this direction, if we just project this is a weight. If we project it over here, we're gonna have sine W sine 20, which this force is equal to, let me just bring it here. Which tau A is equal to weight sine 20 degrees. And tau itself is mu V over B. Because multiplied by A here. Because this is a differentiation of velocity over the gap. So we can distract the velocity out of these equations and equality, which I'm gonna write it here. Let me just erase it and write it in a correct way. We have tau A is equal to W sine 20 degrees, which means that mu V over B multiplied by A is equal to W sine 20, which means that V is equal to B W sine theta sine 20 over mu A. Based on the question, we have 0.001 meter, because this is the gap, which is 0.1 millimeter, and the weight is 10 kilograms. Mu is 0.38 Newton second per square meter, and the area is 0.1 square meter, which is specified in the question. We have this mu based on 60 degrees of Fahrenheit for SAE 30 oil. Doing the multiplication, we're going to have the velocity as 0.0883 meter per second as a v. This is just a substitution, guys. It's not a pretty big deal. If you have any questions about this question, you can put your questions in the comment or in a ways I'm going to provide at the end of this video. Follow me with the third question. Welcome to the third question and the last question. This third question number is, excuse me guys, Welcome guys to the third and last question. The third question number is 1.96 from section vapor pressure, section 1.8. In this question, we are going to have to verify the pressure exerted on a surface, which is something like that, based on the question. There's a semicircle over here, and we have a plane over here, which is delta L, length R in here, and pressures are to the outside. We have a pressure to this center, which is P to RL, and surface tensions, which are sigma to delta L's, and there's also delta L in here. Based on equilibrium, these two forces have to be equal, which means that sigma is equal to 2 delta L equal to P to R delta L's. We can omit the same terms, which means delta L, 2, 2. And let me just, yeah, we have done it correctly. So P is going to be equal to sigma over R, which we have R as 12 divided by 2 multiplied by 10 to the power minus 3 meters, because it is verified in the question that the diameter is 12 millimeters. And the sigma is said to be 7.34. Yeah, 7. Just verify it in this way. Uh, 7.34 multiplied by 10 to power minus 2, yeah, Newton per meter, yeah, Newton per meter, which is sigma. Excuse me. So, doing the calculation, we are going to have pressure as 12, let me just write it here, pressure as 12.2 pascals, which is Newton per square meter. We have meter here and Newton per meter for sigma. Doing the calculation, we're going to have 12.2 Pascal or Newton per square meters. Thank you guys for accompanying me through this section. I hope you have learned everything in a correct and sufficient manner. Please don't hesitate to ask your questions in the comment or in a ways I'm going to provide you at the end of this section. Thank you for everything. Have a nice day.